Hey everyone, today let's look into my favorite topic in the system design, that is caching. So, why is the reason we go for caching? Well, it is to increase the performance of our system by decreasing the latency and increasing the throughput. So if we were to not use a cache, for every request from the client, we would need to read our database, which involves costly disk input and output access. But if we were to put frequently accessed data in memory via a cache, we could increase the number of requests we serve and we can serve them faster. So let's now look into various types of caches. First one that we have is a write through cache. This is a caching system where writes go through the cache and a write is confirmed only when this write succeed both in DB as well as in the cache. So this is really useful for application which write and reread the information quickly as it can be directly served from the cache. However, in this case, the write latency will be higher because we are having to write into two separate systems to successfully acknowledge a write. The next we have is a write around cache. This is a caching system where write directly goes to the DB. And when the cache system reads the information from the DB in case of a miss, uh, while this ensures a reduced write load, write latency, because we only have to write to our DB. This can lead to higher read latencies because there is more misses in this case if the data is reread quickly. Last but not the least, we have the write back cache. This is a caching system where write is directly done to the cache and it is confirmed, and later on it is asynchronously written into the DB. This would lead to a really quick write latency and a high throughput. But as in the case with any non-persistent or in-memory write, we stand the risk of losing the data if the caching layer dies before writing it into the DB. So to improve our odds, we can introduce multiple caching servers while acknowledging a write, so that we don't lose the data and we have at least one replica which has the data and which can asynchronously sync that into the database. So depending on the use case, one may choose which kind of the cache they need. So to maintain high availability and reduce failures, usually cache servers are operated using a heartbeat mechanism, where a heartbeat is a signal that is generated at regular intervals to indicate that something is working correctly or not, and typically it operates at a frequency of 2 Hz. So for large volumes of correlated data for write-heavy systems, we can perform certain caching optimization. First one being offline updates. For so if you assume that most queries appear n number of times in an hour, we can have an offline hash map which keep maintaining a map for every query to its frequency. It's only when the frequency become a multiple of a threshold we go into the DB and update it. So the hash map being a separate data store would not collide with the actual DB. So this is offline updates. The next optimization we can do is sampling, wherein if we assume large scale data with high correlation, most frequent queries would appear a lot of times in an hour. So, as such, instead of using every query to update, we can sample one among n queries and update the data using an estimate from it. So sampling gives you only a probabilistic data, but for high volumes of data, let's say for a system like an autocomplete, where the volume of data is so high you just need a probabilistic measure to know what should be the next word that you are suggesting. Sampling would be fine. So, if your application service is spread across a vast geographic area, then content delivery networks or CDN comes into play. A CDN is a system of distributed servers that deliver web content to a user based on the geographic location of the user, the origin of web page, and the content delivery server. So, as CDNs replicate the content in multiple places across the globe, there's a better chance of data being closer to the user, and there only need to be a few hops between the data server to actually get the data. So CDN machines make heavy use of caching and mostly serve data out of memory. So the less popular data that are not cached by the CDNs can be served in various data centers, or even from the data center which is far away, which has all the data. So Open Connect by Netflix is one of the best CDN networks for streaming videos currently, and for any kind of streaming application, content delivery networks are very common. So when it comes to deciding which cache to choose, following factors come into play. The first one being the obvious, that is the read and write latency, indicating how much speed up we get by using the cache in our system. Followed by that, we have the memory usage, which tells us how much resource we need to maintain this cache. The next factor is the disk IO dumping, which dictates the overhead that lies with connecting our cache layer with the DB. And last but not the least, we need to benchmark our cache metrics across varying scales of data to know how the cache performance parameters vary by scale, by the changing scale of our data. Okay, so the two most widely accepted industrial solution to caching is Redis and Memcached. So Memcache is designed for keeping simplicity in mind. So that is when the cache is relatively small and serves static data, Memcache could be used. While Redis offers a rich set of features that make it effective for a wide range of use cases. So for most scenarios, the pros of Redis outweigh that of Memcache, and only for simple scenarios where you just need to deploy something so quickly, you would be really preferring Memcache. So that covers most of the topics that's there in caching layer of system design. Thanks for watching, guys. See you on the next one.